particular set of data, the p-value that is obtained from the calculator is actually 6.3 times 10 to the power of negative 4. That is, the p-value in our case is 6.33 times 10 to the power of negative 4, which is a very small number, which you can rewrite it as 0.00633. What does the p-value tell us? Well, the p-value basically is the probability that we will wrongly reject the null hypothesis, that is, the two events are actually independent, when it is actually true. In another word, if we choose to reject the hypothesis that the two events, in this case that color and gender are independent, then we run the probability of 0.00633, which is a very, very small number, of making a mistake when independence is actually true. So what we can know is that we have a degree of freedom of 3 and that we want a 5% significance levels. The next step is to refer to a table. And from the table, we find that the answer to this is roughly 7.815 to 3 decimal places. So then the conclusion that we can make is this. That is, since the chi-square calculated statistics is only 17.2, which is larger than the critical value of 7.815 at 5%. That is, if you take a 5% risk, all right, this is the critical value, and this is a lot larger than 7.815. So we have to consider this number to be big. So if you consider this number to be big, then the conclusion is that we must reject the null hypothesis. That is, we have to conclude, based on the data, that the choice of the color for phone cover is not independent of gender. So all we know is that they're not independent. We do not know what the relationship is about. In recent years, statisticians now prefer to report the p-value instead of using the significant figures of 5%, 1%, or 10%, which is like imposing on people's this certain tolerance or risk. By reporting the p-value, the researcher gives the reader a choice to make the decision themselves, whether they want to accept or not accept, depending on their tolerance level. And this is actually more objective because it tells you what's the probability of making a mistake if you choose to reject the null hypothesis.